Okay.
All right, so the first type of problem that you need to know, it involves the power series, which I kind of went over with Julia separately. But basically what you're doing, I kind of explained this at the beginning, but you need to figure out when it converges and when it diverges. The series. That's literally the whole point of this chapter. And that's basically what we're going to be testing. But when you add an x value, like whenever you add an x, I know Julia, you told me like that these problems are special because there's now an x in them. It's not just with respect to n. When you add an x, now it doesn't have to always be either divergent or convergent. It can be convergent on like a certain interval, so like from 1 to 2. Does that make sense?
Okay.
That's basically what we're doing. Before, like think back. Before you were just saying, oh, it's divergent, oh, it's convergent. Now we're trying to figure out when it's convergent. So we're never going to have a divergent problem for these. We're just trying to figure out on what interval is it convergent. So it could be 1 to 2. For this one, it's negative infinity to infinity. So it's always going to be convergent. And that's basically what we're testing. Does that make sense, Julia?
Yeah.
All right. Um, so let's do this problem. And the way you solve it, Julia, is by doing the power series, which is basically the same thing as the ratio test. So do you want to set this one up, Julia? Because we were kind of like doing it like yesterday
Yeah. So
as a
this
test.
with A of n, right?
Yeah. Remember, it's a of n. You figure out what a of n is first, and then a of n plus 1 is. That's how you set up the ratio test.
Okay. So A of n is 2x to the n over 3n factorial.
Yes.
And then A of n plus 1 is 2x to the n plus 1 over
Okay.
3n plus 1.
No.
3.
Julia, think about it. You're plugging in n plus 1 whenever you're seeing n. If I plug in n plus 1 over here, this becomes 3n plus 3, right?
Yes.
So it's not 3n plus 1, it's 3n plus 3. Does that make sense?
Yeah.
All right. And that's pretty much it, Julia. Now all we're gonna do is set up the ratio test. Which, as you guys may or may not remember, you're basically plugging in what you just found. So it's the limit as n approaches infinity, and you're taking the absolute value of a to the n plus 1 over a to the n. And remember, if it's less than 1, it converges. So we're going to set that up a little bit later, but let's like solve this one first. All right. So the first thing that we have, the limit as n approaches infinity, a to the n plus 1 is 2x n plus 1 over 3n plus 3 factorial all over 2x to the n over 3n factorial. And I got this from right over here, and I got this from right over there. And that's basically where I plugged in each value. Now, and Julia, I want you to help me simplify this.
Okay.
Now we're gonna like start canceling some things out. So let me erase everything on the top because we don't need that anymore. And we already know what a to the n plus 1 is pretty much. All right, so I'll write this in red. I'm basically going to continue the work starting from the top. So the limit as n approaches infinity. I'm going to keep the absolute value because we're dealing with x's, so we don't know which values are going to go in. But it's 2 to the x n plus 1 over 3n plus 3 factorial. Keep, change, flip. So this is now 3n factorial over 2x to the n. And have I lost Kate and Aaron? Have we lost you guys yet? Or like you guys are following along?
I'm following along. I get it.
Yeah, I'm
Kate?
following.
Okay, perfect. All right, so Julia, I want you to help me simplify this. How can I rewrite some of these so they can cancel out with each other? Because that's basically the point. Like Kate, like you don't like I wouldn't know to take this limit unless like some of these things started to cancel out, like the exponent to the n, the factorial. It just makes it like easier for us because we have to take the limit essentially. So Julia, what can we cancel out, or what can we rewrite?
So you write 2x of n times 2x, and the 2x of n will cancel out with the other 2x of n.
Okay, wait, hold up. So you're telling me it's 2x to the n times 2x. That's correct.
Let me figure out.
So hold up. Let me just write what you said so far. So you're telling me that this one and this one cancel out, right?
Yeah.
Okay, that's good. Now what about the factorial?
Okay. The one with the factorials where I find myself getting more stuck on. So this would be 3n plus 3, but it's minus 1. So would it be 3n plus 2? Is it
Well,
that?
remember, if you want to rewrite a factorial, you just start doing minus 1, minus 1, minus 1. So this is really equal to 3n plus 3 times 3n plus 2
Times 3n plus 1
times
times
3n. But we want to stop there because that's the one we want to cancel out, 3n factorial.
yeah.
So really,
So do we have to
basically,
plot that under that?
yeah, we do, because that's all a part of the expression. It's kind of long, but like it really is like all a part of the expression. So now this one and this one cancel out. So
Yeah.
now, and that will just work on the bottom just so you can see the factorial like being simplified. But for this problem, now what we're left with, oops, sorry. Now what we're left with is this, a 2x on the top and a whole bunch of like 3n's and stuff on the bottom. So that makes sense, right, Julia?
Yeah.
All right. What's the next step we do? What do you remember?
Wait. Let me write this down. The next step is to plug in infinity.
No, there's an x there. Remember what we did the other day?
You take out the x, right?
Yep, exactly. So you move the x to the outside because you can't take the limit of something with respect to n if you have multiple variables. Like they're not all with respect to n. So basically what you're left with when you move the x to the outside, and remember it's the absolute value of x because we never got rid of them. So I just moved the absolute value of x to the front of the whole expression. So basically what we're left with now is 3n plus 3, 3n plus 2, a whole bunch of like 3n's and whatever. And we're trying to see when this is less than 1. Because according to the ratio test, if the formula that we did from the beginning, like all of this, if this is less than 1, then it converges. And we're trying to find the interval of convergence. I know I kind of blocked it out, but you can see it right here. Interval of convergence. That's the whole point of this.
Okay.
So yeah, I mean, at this point, we need to figure out what that limit is, but the limit of that is literally 0 because when you plug in something with infinity and there's like a whole bunch of n's on the bottom, it's gonna be 0. So you're left with the absolute value of 2x
So
times 0.
if it's bigger on the bottom, it's 0, and if it's bigger on top, it's infinity.
Yes.
Yeah, I always forget that.
So at this point now, we've figured out that when you like that, the limit of this expression is 0. And now's when I want you to think about the interval, right? An interval is basically telling you when it's convergent. So I'll kind of go into like the other parts of this further on, but the center of this like series is 0, and we're trying to figure out when it's gonna be convergent, right? I basically just drew a number line. So we know that for like look at this expression right over here. For any value of x that you plug in, it's going to be less than 1 because there's always going to be that 0 there, and you're always going to have to multiply it, and therefore you're never going to plug in a value of x that will give you something less than 1. So on this interval, you can plug in 1, So you can plug in 1, you can plug in 2, you can plug in -1, you can plug in 2, -2. You can literally plug in -9999, and it's going to give you the same answer. So the interval of convergence for this power series is -infinity to infinity, because you can plug in any of these and you're going to get less than 1. Does that make sense?
Yeah, for sure.
Okay, perfect. They're normally not this easy. Like, you're normally not going to get one that's -infinity to infinity, but the one you do get one, it's like like less work, because you know now that any single number you plug in, you're going to get less than 1. It's going to converge according to the ratio test. So that is how you do this first one. So I'm going to move on to the next one now. And now I'm going to teach you guys a little more about like the terminology for intervals, at least intervals like with power series. So remember the interval I just showed you?
Yeah.
Here, I'm gonna draw it again. There's always gonna be a center, and then there's always gonna be a radius. So I don't know if that makes sense. So the center is just gonna be the middle of like the whole series, and then the radius is gonna be like, think about it like a circle. Like the radius is like the halfway point here. So the radius, if this is our center right here, and the halfway point of the circle is it's not letting me change the color. If the halfway point is this, then if this is our center right here, the halfway point is this, right? And let's say that it ends right here. That's basically the radius. And notice how 2 of the questions you're asking where it's centered and where the radius is.
Is +1.
Yes, the center is not, yeah, that's what it is. The center is always going to be like, okay, when you're looking for the center, you're always going to look for it where, and yeah, I guess you saw the answer right there. Oh, you didn't see it? Okay, good. Whenever you're looking for the center, look for where the x's are. The x is this expression right here, x minus 1 to the n. And the form of a center is x minus c, where c is equal to the center. So just like using like comparing them, you get that the c has to be equal to 1, and that's why it's 1. So does that make sense? Yes?
Yes.
Okay. So we now know that the center is 1. I'm gonna put it on the top right now because we're gonna have to do what we just did before to figure out the interval. But at this point, we haven't, I would say, like we haven't we don't need it yet. We don't need the center. We're just gonna write it here, and that's the answer. The radius of convergence. So in order to find the radius of convergence, we now know that the center is 1. We need to figure out what these 2 values are so that we can kind of do like a halfway point. You can figure out what the radius is, the distance between the center and point A, and then the distance between the center and point B. It's going to be the same. So let's do the power series again, because in order to figure that out, we're going to have to do the power series. So let's see. So Julia, what is a sub n and what is a sub n plus 1? Because remember, that's like the first thing you have to do when you're doing the power series.
Okay, so a sub n is -1 n x minus
Wait,
1.
what?
I don't know. I think it's -1 n.
Julia, a sub n is always going to be what you have here.
But then if it's so, then the a sub n1 would be -1 n plus 2.
Yes, exactly. Your a sub n is what you're copying from the expression. A sub n plus 1 is you're adding n plus 1 to everything that's already there. Does that make sense?
Yeah.
So for this particular expression, a sub n is -1 to the n plus 1 times x minus 1 to the n over the square root of n. And then the one over here is like exactly what you said, n plus 2, x minus 1, n plus 1, because that one was formerly n, and now it's the square root of n plus 1. So now we're basically gonna do what we've done before. We're gonna plug it in here. Remember, it's this one over this one. So it's this n plus 2 x minus 1 n plus 1 over the square root of n plus 1 all over this. And I can already tell you guys that like this, you can already kind of like start simplifying because you're taking the absolute value of this, and since this is -1, it's kind of going to go away because it's not going to be important. When you take the absolute value of something, when you take the absolute value of a -1, it's just going to become 1. So nothing happens to it. It's just going to become 1. Does that make sense?
Yeah.
So I'm not even going to worry about like canceling those out because that's going to be difficult. But let's continue.
Keep change flip.
Yes, we're going to do keep change flip. So we have x minus 1, and I'm just going to write it like this. X minus 1 to the n times x minus 1, because that's what it is, over the square root of n plus 1 times the square root of n, keep change flip, over x minus 1 to the n.
Wait.
So, yes?
Hold on. Let me catch up 2 seconds. It's because I lost myself because sorry.
Wait, which part did I lose you with?
No, it was because like I was watching you talk about the canceling out of the -1 thing, but then like I don't know, I didn't process it. But wait, I'm still never mind. I'm confused on that because this is n plus 2 and that's an n plus 1. Why did you say again that they can cancel out?
What do you mean? Like the negative ones?
It's because they're -1. So even if the exponent comes out, so that if it's like n to the third base or -1 to the third, and that's like -1, because it's an absolute value, it will always equal 1. So 1 times anything is always itself. So we can just cancel that out to save time.
That's exactly how I would explain
Hey.
it. Does that make sense, Julia?
It's because I wouldn't have canceled it out because it said n plus 2. And so
But Julia, like
Hmm.
it says n plus 2, but it's still a -1, right?
Yeah, but then when you multiply it times 1, it would be n plus 2 and n plus 1.
Well, like if it's here, let me kind of like do this on the top. If it's -1 to the n, that means that when n is equal to 1, you're gonna get -1. When n is equal to 2, you're gonna get 1. When it's equal to 3, you're gonna get -1. Do you see how I'm plugging in different n values?
Yeah.
Right. But when you take the absolute value of this is gonna become positive. This was already positive, and this is gonna become positive. So no matter what n value you plug in, you're gonna get a +1 because it's the absolute value.
Okay, I get it.
It
I'm sorry. I just realized.
doesn't make sense though.
Yeah, I just realized.
Okay.
I forgot that they become an exponent and the exponent. Yeah, I know what you guys mean now. I'm sorry.
Don't worry. That's the whole point of this. So I'm gonna cancel these out. Going back to what we have over here. Cancel, cancel. Nothing else can be canceled. So I'm gonna erase work over here. Work. And then I'm gonna rewrite this. But I'm gonna move this one. Oh, sorry. Well, you guys get what I'm trying to say. I'm gonna move the x minus 1 to the outside because that has an x term and we're trying to figure out the limit. So I'm moving this absolute value of x minus 1 to the outside. And the limit now, all we're left with is the square root of n over the square root of n plus 1.
Wait,
And remember, we're trying to see if it's less than 1.
give me a second. Give me a second. Hold on.
Well, Julia, like I would say like focus on like paying attention now because like if we try to copy everything, like I don't know if we'll have enough time. So like try to understand it through video because I'm the same way. Like when I'm doing notes and I'm like too focused on copying it, then like I lose track of like the lesson. But like these are all problems from the Just Do It. So if you want the work for each individual one, ask me and I'll literally send it to you like through through text. But like make sure you're understanding like what's on the screen because that's like the most important, you know?
Yeah. Okay, okay. Continue. I'm sorry.
So like I guess like on your like Just Do It, the one that I sent you, you can write like key tips for you. But if you want the actual like thorough work, I'll literally send you each one like from my just do it, so that you have it. But like at least for now, like just so that yeah. So I wasn't ask you, Julia. I want you to tell me the limit of this. What is that?
The limit of that is 0.
Why?
Well, my guess is because
Why
if
would it be 0? Remember that it's you're always looking at the exponent to see which one is bigger. Aren't these both to the 1/2 when you think about it?
yeah, true.
And what's the rule about like if it's to the 1/2?
You have to use the coefficients, don't you?
Yes, yes.
Okay.
What's the coefficient of both?
1.
Well, the coefficient of both is technically the square root of 1. You get me? Because there's a square in front of it.
Okay.
But for this particular situation, it doesn't matter. So tell me what it is. What is that limit?
It's just 1.
It's 1. That's right.
Okay. Okay.
So you're left with the absolute value of x minus 1 times 1 has to be less than 1. Remember, less than 1 because that's the rule of the whole thing, the whole point of this lesson, the ratio test. But now is when we're figuring out which x values it is. Because remember before we had a 0 here, so it made all of them less than 1. Now we don't have that. So now we're gonna have to do some solving. So here's the rule, Julia. In order to get rid of the absolute value and figure out the interval, all you have to do is rewrite this as you rewrite it without the absolute value, but you just put a -1 on the other side. Does that kind of ring a bell?
Yeah.
That's all you have to do. In order to go from here to this, that's what you do. You write a -1 on the other side and you take out the absolute value. And now is when you can do like manipulation. So we just want x by itself. Because remember, think of the number line. We're doing this like an interval. So we're trying to figure out like something in parentheses. Oh, I don't know what happened, but that text went away. I'm not sure why, but okay, I guess I'll keep going. So that's what we're doing, an interval, like the parentheses. We're trying to figure out from where to where it works. And this is the same thing. So basically in order to solve this, we're gonna do +1 on all 3, just that we're left with x by itself, and we're left with this from 0 to x to 2. So at this point, let me erase everything on the top. Let's go back. Let's go back to the beginning of the problem. Remember, I drew a number line that looked like this. We said the center was 1, and now we figured out like our endpoints. It's gonna be somewhere in between this little area. So we know that one endpoint is 0, the other endpoint is 2. We can't do the interval just yet because there's a test we have to do to make sure that whether it's a closed parenthesis or a bracket, but we can figure out the radius because so one of you, what do you think the radius is for this particular like little thing?
It's 1.
It's 1. That's how you get there. I don't know why I keep doing that, but the radius is 1. And if you go to the bottom of this, you can see that the answer for part B is 1. So now, look, okay, so we're at the point right now where we know that it's going to be from 0 to 2. You just can't tell me if it's a bracket or in other like terms. We don't know if it's a bracket or it could be a closed dot or a parentheses or an open dot. Does that ring about like do you know how that works, Julia? Do you remember?
Vaguely.
Remember, brackets mean that you include that value in the expression. 2 means that like you can't include the 2. You can't include the 2. Does that ring any bells?
Isn't it the square one? The one where you can't include it, and the like curvy one, the one where you can?
No. I mean, I don't know what you're talking about, but it's
No.
always been
She means the bracket in the parentheses. Yeah, you're right. The square one you include it, the parentheses you don't.
I
Oh,
thought
okay.
it was the opposite.
No, a bracket means that you include it. 2 means that it's open.
Oh yes, yes, yes. Okay, yes. That's how I thought about it, but like because I thought, oh, it's open, that means that the two is it's like from two forward.
Okay, so now we're gonna have to test these values to see if they're open parentheses or if they're closed parentheses. How do we do that? Well, we plug it into the original expression and we see if it converges at that value or if it diverges.
Oh my gosh.
So this is like the throwback to the previous chapter. So it may be like, I don't know. I'm gonna do it and see if it rings any bells. Okay.
Okay.
So we're gonna plug in 0. -1 to the n plus 1. I'm gonna plug in 0 right here. And we're left with this. -1 to the n plus 1 over -1 to the n over the square root of n. And since these have the same base, we can combine them together. You just have to add the exponents. So now we're just left with -1 to the 2n plus 1 over the square root of n. So the series is actually a P series because this can just simply be rewritten as -1 over the square root of n, because let's look at this expression. Sorry. Let me erase most of this work over here. So when you look at this expression, -1 to the 2n plus 1, for every n value that you plug in, let's plug in a few. 3, 4, and that's really messy, but when you plug in 1, you get -1 to the 3, which is -1. When you plug in 2, which is -1, sorry, you get -1. When you plug in 2, you get -1 to the 5, which is -1. When you plug in 3, you get -1 to the 7, which is -1, so on and so forth. So it's always going to be -1, so I just wrote -1 there instead of all the exponents. Does that make sense?
Yeah.
So this is a divergent P series, because this is technically -1 over n to the 1/2. And if you remember the P series test, when P is equal to something that's less than 1, it diverges. So the whole point of this, we plugged in x is equal to 0, remember? When we plugged in that, we got divergent. So that means we can't include it. It's going to be in open parentheses because we literally just plugged it in and we figured out it doesn't converge here. It diverges here. So it has to be open parentheses because this interval is literally telling us, it's telling us which x values can I plug in so that it converges. And we know now that we can't plug in 0 because it diverges here. Does that make sense?
Yeah.
Okay, so now we're gonna do all of this work and test out the other side of it, the other side of the interval that we figured out, which is that x is equal to 2. Let me clear that. So at this point, sorry, the center is 1, 0, and this is 2. We figured out that this is an open circle. We just need to figure out the status of this other circle. So when x is equal to 2, let's plug it in. Remember, you're plugging in x's, not n's. So it's 2 minus 1 to the n. And Julia, please stop me if I lose you. Like, please, don't worry. Okay.
Okay.
So I plugged in the x right here, where I see it. You're left with -1 to the n plus 1. This is a 1 to the n over the square root of n. 1 to the n, think about it. For every n you're going to plug in, you're going to get 1. So we don't even need it. But Julia, I want you to tell me why we can't, for this leftover expression over here, the -1 to the n plus 1, why we can't just say that it's always going to be -1. or why we can't always say it's going to be 1, like we just did to this one. Do you
Because
know why?
negative.
What?
Because it's negative?
No, but Julia, remember for the previous one, we said this can be simplified to just, oh my God, why does this keep doing that? We said that this can be simplified to just -1. Because it's always going to be -1.
Here?
What?
We can't do that here?
No. Because look,
Because it's
think
gonna be
about it.
positive 1.
What?
Because it's going to be positive 1.
No, because it can be negative or positive. It can be both. So we can't say that it's always going to be 1 when it could be either or.
Why didn't you make it 2n plus 1? Like, why didn't you do... I know that, like, when you do the 1 to 1 or 1 to 3, it's always going to be 1. But, like, why didn't you add them? Would
They
it
have to have the same base, remember?
Oh, and they don't have the same base. That's right.
Yeah, one of them has a +1 base, the other one has a negative base. So that's why we can't do it. But do you understand why -1 to the n plus 1 like alternates? That's getting me to what type of series this is. But do you understand why it changes? When you plug in n is equal to 0, for example, you get -1. When you plug in n is equal to 1, this becomes squared, so that's 1. You see how it changes?
Yeah.
And it's gonna go from -1, 1, -1, -1, 1, -1, 1, -1, 1. It's gonna keep doing that. So as I'm sure you can tell by the word that I use, this is actually an alternating series. And this is again one from the previous chapter. So I'm not sure if you guys remember this type of test, but it is an alternating series test that you're gonna have to do to determine if it converges or diverges. I can already tell that this one converges, but I'll do it. So and remember that when you're determining these, you're gonna have to write which tests you used, like on Miss Q's test. So make sure that you're writing them at least. So the alternating series test, you're basically gonna take what's here without the -1. So it's 1 over the square root of n. And you're gonna check for 2 different conditions to see if it works. The first condition is that this expression over here, when you take the limit as it approaches infinity, it has to equal 0, which is true. So that's a check mark. The second condition is that the term to the n plus 1 has to be less than or equal to the term to the n. And since the square root of n plus 1 is less than this one is also true. So because those 2 conditions are met, this converges by the alternating series test. So since it converges at x is equal to 2, this is now a bracket because we know it works. It works in this interval. Does that kind of make sense?
Yeah, but then I'm sorry.
Don't worry.
What did you end up doing then to get it to 1 if you don't know? You did 1, you plugged in 1 and got 2 so that it can be +1. And then the 1 over square root of n is what works for the alternating series test, or did you put alternating series because it can be positive?
Julia, so the alternating series test, so basically the alternating series test is literally the whole point of it is just to see if these 2 conditions work. And it literally says that when you're plugging in when you're trying to figure out how to set it up, you ignore what's here. That's why I just wrote 1. You're ignoring what's here. That's literally the rule of the
I
test.
thought it was because you plugged in the 1 from
I don't plug in any n values here. I didn't do that. All I did was I just got rid of it and made it 1 because all you're doing, you're literally ignoring, pretend that it never existed when you're doing the test. It really does exist. But when you're doing the test off to the side, you can pretend it doesn't exist. Does that make sense?
Yeah.
I know it's weird and there's a lot of different nicks and tricks and things like that you have to remember, but that's how you do it. So at this point we've already figured out that the interval is close parentheses 0 2 bracket, and that's how you do this problem. I'm gonna move on just because I don't want to like completely spend all the time on this, I want to try one of these. Okay, it's taking the derivative of the series. Aaron or any like Julia, do you guys like have any idea how to do this? Or you want me to do like fully, like from scratch?
Do it from scratch because I don't know how to do this at all.
Because
Okay,
the series is just the things that is the ratio test that we've done the first two questions.
this is a new concept.
But it's because of the derivative.
Yeah, this is now you're taking the derivative of a series. So how do you take the derivative of a series? You take it any other way you normally would. But remember that when you're taking the derivative, okay, so we're gonna write f prime of x. When you're taking, okay, let's try this. Let's say that we have something x squared. Take the derivative of that. You bring the exponent to the front, you leave the same x, and you reduce the exponent by 1. So you're left with 2x to the 1, which is just 2x, right?
Uh-huh.
And that's when you're doing the derivative with respect to x. Let's say, and since it's asking for f prime of x, we're taking it with respect to x. So we don't need to look at the ends. Any term with an n, we're not taking the derivative of that. You can just treat it like a coefficient essentially. So maybe this makes a little more sense. Like -1 to the n and 2n factorial, you can just act like it's in the front. And really what you're looking at is the term with the x right over here. Because we're taking it with respect to x. We're not taking it with respect to n. So everything here just stays in the front and we're not taking the derivative of that. You can act like just like how if you're doing the derivative of n to the x, when you take the derivative of that, it's just n. Because at this point, we're only looking at the x and the n is like a coefficient. You can pretend it's a number in the front. Same thing how when you take the derivative of 2x, you're just left with 2. Does that make sense?
Yeah.
Okay. So I haven't lost you guys. That's good. So all we're gonna do is the same exact rule we did before. And what do we do when we take the derivative, Julia?
You bring down the 2n.
The 2n, and what do you do to the one? What do you do to the exponent?
So you subtract it by 1, so it'd be 2nx. Is it 2n minus 1?
Yes, that's it. So all you're left with now, and remember that there's still -1 to the n over 2n factorial. Oh my god, sorry, this is really, really ugly. Let me rewrite this. I'm gonna rewrite it in green. So all we're left with at this point is -1 to the n over 2n factorial. And you told me when you're taking the derivative of the x term, you're left with this. So, Julia, can anything here cancel out?
I mean, can't we make the 2n factorial thing kind of similar to the exponent? But like, that's an exponent. So I don't really know.
Well, look, this is a 2n and this is a 2n factorial. Wouldn't you say those are like very similar?
Yeah.
And how can we rewrite this factorial so that we're just left with a 2n?
It's 2n minus 1, which is
2n times 2n
minus 1.
minus 1, which is really 2n minus 2 when you think about it. So that's what it looks like. Basically, all we're left with is 2n times 2n minus 2 factorial, right?
Yeah.
So now this can be rewritten as 2n times 2n minus 2 factorial because all we're doing is doing -1. The reason why it has 2n minus 2 is because the 2 in the front makes it -2, but it's still -1.
But like,
What?
I didn't think you could do it because the 2n minus 1 thing. Wait, Why didn't you continue? Well, because since it's negative, it would have been 2n minus 3, right?
What do you mean?
I don't know now. Okay, you did 2n and then 2n minus 1, but you distributed the n so it became 2n minus 2.
The
But
next term, here, let me erase some of this.
it's like still different from the 2n minus 1.
Look, it's the same exact rule as before. You're just writing n minus 1. You're doing a minus 1. You're doing a minus 1. So, actually, wait. Give me 1 second, just so that I can double check. I want to make sure that I'm telling you the right thing. I'm pretty sure I am. But this is not the wrong. This is not the wrong one. Give me 1 second. So this is number, I think, 5 of one of the Just Do It's. This is asking us to take the derivative. No, that's an integral. Which is the one of the derivative. Is it this one? No.
I'm vibrating.
That's my. I'm sorry. That's my phone.
Oh.
I told you the wrong thing. Ignore literally what I just said. It's literally what you said. I'm very tired.
Okay.
You're right. I was checking my notes because I knew like I wasn't like I knew something in my head was not sounding right. It's literally what you said. It's 2 minus 1. Don't worry.
Okay.
And then the next one, what would the next one be? 2n minus 2, 2n minus 3. It's exactly what you're saying. Because you're not plugging in n minus 1. You're just doing a minus 1. That makes sense, right, Julia?
Kind of. Now I don't know what I was right about. So
I told you. Okay, so look,
2n and then that's 2n minus 1, but then you said that
wait, hold up. I'm just gonna rewrite this because we're taking the derivative. This is f. You can't write the f prime. Prime of x n is equal to 0. Negative 1 to the n, 2n factorial. We took the derivative of this, so we're left with 2n, x minus 2n minus 1.
I was left off.
What?
It's like where my brain left off.
Okay, so now, remember, the whole point is that we're trying to cancel the 2n.
Yes.
So 2n, x, 2n minus 1. And how do we do that? We're going to say this is 2n times 2n minus 1 factorial. Does that make sense?
Yeah, okay.
Okay. These cancel. So we're left with, and let me just avoid writing something right there. We're left with f prime of x is equal to negative 1 to the n, x to the 2n minus 1 over 2n minus 1 factorial.
Joseph,
That's the
you can
that's
just
the
cross out the 2n on the top despite the 2n being part of the x.
it's just a number in the front. Does that make sense? It's a coefficient. You're
So that
multiplying.
it doesn't belong to the whole thing, it just belongs to the x.
What do you mean?
Like that.
When you're multiplying, it belongs to everyone. Since these are all being multiplied together, they're just like they're all together. Like they're all traveling the same pack.
Okay.
Does that make sense?
I mean, like, yes, I guess. Yes.
It's just like this, Julia. Like when you take the
Yeah,
derivative, yeah, like if you have this, like the 2 is just in front, you can still cancel it, right?
yeah.
You would cancel it that way, right?
It's like a coefficient. Yeah, yeah, I would. It's just a coefficient.
Yeah, that's the thing. All right. So let me erase. So at this point, we're kind of at the point right now where it's again something kind of new. Notice how I wrote the whole, notice how it's the exact same answer here, except I haven't written anything here yet. And that's because we're gonna have to do something to figure out when it starts.
So you took away the one that was there? I mean,
What
the
do you
zero
mean?
that was there? Because we used to have a
It's
zero.
not a zero. It's just we haven't figured out when it starts yet.
Okay, because my question is, I would always get confused because I understood what you meant to when you explained to me yesterday that like you have to find something because zero won't work. But if zero doesn't work, then why don't they just put n equals an empty space? Why do they write zero? Because then I won't like to me, I feel like I won't know on the test that I'm supposed to put a number for n because like they already gave me a number.
Say that again.
Okay. Why doesn't it why like if zero doesn't belong there because when you do the whole thing you get zero and that doesn't exist, then why do they put zero on the problem? Why don't they just put n equals like a space? Because either way we don't plug in n until right now.
Look, Julia. Okay, so you're asking about. Hold on, let me erase
Like
this.
how will I know that I
You're
know
asking. Wait. You're asking why zero doesn't go into this original one.
I'm asking how will I know that I have to change it from zero to something else? Because other problems just leave what the problem gave me.
Okay, so I'm telling you the reason why we're changing it is because we took the derivative. That's the only reason why. When you take the derivative in the integral, the thing is you never know if it's gonna stay the same or if it's gonna go to a different number. But
Okay.
yeah, that's the only reason why.
But
But
yet
Julia,
didn't we do a problem where because if you plug in zero, 1/0 doesn't exist, so you have to change it?
no, because they're never. I changed it because that was me writing a bad problem. That's never gonna happen to you. This actually exists. That
Okay.
exists because 2 times 0 factorial, 0 factorial, if you remember, is actually 1. So that's why it's not 0. So it actually works. Does that make sense?
Yeah, yeah. Now it makes sense.
Okay. So here's what we're gonna do. In order to figure out where it starts, we're gonna look at our old example, like for reference. So I suggest that when you're taking the derivative, remember, we took the derivative of this original expression. I'm going to write it here. You should write out a few terms just to see what it looks like. That's what my suggestion is. So when you plug in 0, you're just going to be left with, Julia, do you want me to actually plug it in, like, and show the work, or do you want me to do it in my head?
You could do it in your head.
So when I plug in 0, I'm going to be left with, I'll write this one out because this one's, 0 is always a little weird. You're left with x to the 0. This is -1 to the 0. 2. You're going to be left with 1. That's what you're going to be left with. So this whole thing, this first term is 1. Plug in 1, Julia, and tell me what you get
Into that problem?
into this problem. What do you get when you plug in n is equal to 1? So what's your second term?
Okay, so -1 to 1 is just -1.
So I'm going to write a negative sign because that only affects if it's positive or negative. Next.
And then x to 2 times 1 is just x squared. Because
X squared, right? That's what you said?
yeah, I said x squared.
Perfect.
And
Next.
then 2 times n is just 2, and then 2 factorial is 2 times 1, which is 2.
Perfect. Okay, what's the next term?
Is 3. So
Wait.
-1.
We plugged in n is equal to 0 here. We plugged in n is equal to 2 here. I'm sorry. We plugged in n is equal to 1 here.
Oh,
What do we do?
2.
Yeah.
So then it's gonna be +1 x to the 4th.
Yes. You can just write 4 factorial.
Okay.
You
Yeah.
do not
Do the whole thing.
do not like you could literally even just leave this one as a factorial if you want.
Okay. So that's what you have to do next. But then why did we find the derivative and all this stuff if we're just gonna go
Because here's another way you can take the derivative.
like
You can take the derivative by just taking the derivative of each term.
so we could have avoided the work that we done.
No, we have to do this. We have to do this too. That's the thing. Because now I'm gonna write this derivative on the bottom.
I don't get why we did the derivative if we're just gonna
Because the whole point of this is to figure out when this new term starts. I'm putting a red box there because we don't know what it is. We don't know when it starts. I know it says 1 right here, but Judah, can you tell me why it says 1?
where
Do you understand why it went from 0 over here to now 1?
to now 1.
Look at the answer key.
Oh, it's because 1 works.
1 works, but how do we know that? How do you know that without plugging in the values?
Wait, we plugged in 0, then 1, then 2 up there, and we got
Yes.
those terms. And what do we do with those terms to get then, like, to know what the value is for the prime one, the derivative?
What?
So then we came up with those terms. How do we use those terms in order to come up with what n equals for what for the derivative?
So now, here's the thing. We're going to take the derivative. Look, we in order to get from this yellow part that I'm boxing to this, we took the derivative, right?
Yeah.
So in order to get from this to the terms over here,
We
we're
have
just
to
going to take the derivative.
Okay, I see.
So the first derivative of this term is 0, right?
Yes.
The derivative of 1 is 0. The derivative of this term, I'm going to bring the exponent down. You're left with a 2. That's to the 1. And that's a 2 factorial, right? Do you understand me right, like so far?
Yeah.
The next one, I'm going to bring the exponent down. I'm left with this. This is 4 factorial. And now I'm going to erase all this because we're done with this original expression essentially. Now we know the terms. Now we know the terms of this expression. We know them. So now 0 when you it's not we can't consider this because 0 is not the first term. The official first term of this expression is 2 factorial plus 4x cubed over 4 factorial minus dot 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 dot. We're not worried about that. So now, Julia, I want you to tell me which value of this when you plug in this. Oh, sorry. I'm going to tell you that this can be actually simplified to negative x. And this can be simplified to this. This will make it a little bit easier.
Yeah, because we just cross out the 4s and stuff. Like,
Yeah. You understand how that works, right?
well, I don't understand how you go from 4 factorial to 3 factorial.
Well, look, 4x cubed. 4 factorial is 4 times 3 times 2 times 1.
Oh, okay.
Does that make sense?
Yeah.
Okay. So, I'm sorry. I'll tell you later, Julia. So we know that the first term, I'm sorry, like this is honestly very long and complicated. Like I apologize. Like it really is. Like I'm not gonna like sugarcoat it. I'm sorry. Like it really is. Like it's a lot of work.
It's okay. It's not your fault.
So what n value will give you negative x when you plug it in? 1. And that's why the answer is 1.
Will give me negative x value?
What n value over here will give you this term, and it's 1.
Yes. Okay, perfect.
If you're not sure, let's try the next one. Which value will give you x cubed over 3? Well, I'm going to look at the exponent. There's only one way to get x to the 3, and it's when you plug in n is equal to 2. So that must be the second term, which means that we're right. The first term is 1. Does that make sense?
Yes,
Okay.
that makes perfect sense.
Ooh, I'm sorry. Okay, we're literally on number 3. I literally, like,
I know.
there's an integral 1. There's an integral 2. There's literally an integral 2. Like, there really is. Like, it's the same, and it's the same process.
But number 5, for example, is the same thing that we already did, right?
Number 5 is different.
It is.
So here's what we've done so far. We've done a power series. That was the first thing. The second thing we are doing is deriv/integral. What we're missing is geometric. We're missing Taylor/Maclaurin. And we're also missing like elementary functions, but these two go hand in hand.
I thought
So
5 was more or less this. Oh no, it's not because it looks different. It doesn't have the something.
yeah, so I'm gonna tell you that whenever you have something that looks like this, you need to think of the geometric form of a power series. And I think this is like the one I explained in class that one time when you guys were like, "Oh, I understand it." So I'm gonna re-explain this, and then I'm gonna go to the Taylor Maclaurin because Taylor Maclaurin is the easiest one, and I want you to get points for that. Like, I want you to get like those right. Like, I understand that it's hard to learn everything like all at once. Like, it is like a very long chapter and it's very strenuous. But I know you can get points for Taylor Maclaurin, and I want to spend time on that so that like, it's worth your while, if that makes sense.
Yeah, because I can probably do Taylor Maclaurin and then also the power series, like the 1 and 2 that we did. And the
Yeah.
third.
So here, I'm gonna tell you why we know that this is a geometric power series. We know because the form of a geometric power series. Here, this is like the official form. It always starts at 0, so now we don't have to worry about that whole thing, the whole mess about where it starts. This is what it looks like, and we know that a minus 1 over r is the same thing as the series. So notice how it kind of looks like what we have over here.
Yeah.
So now all we have to do is kind of match. Look, it's literally a matching game. We're gonna match what's here over here with here, so we can plug it in over here, and that's the answer. Does that make sense?
Yes.
Because all we need to do is figure out what A is, what R is, and then we can just plug them in right there. Does that make sense?
A is 1.
So,
A is
I
not.
want look. I want you to pay very close attention to this formula. A minus 1 over R. Notice how it kind of looks like it, but it doesn't look exactly. And that's the goal of this. So first and foremost, we have to, like, your R value is always going to be with the one with the X. So look, this can be rewritten as 4 plus X, right? All I did was flip them. X was over 4 plus X. That's like second grade, like complementary rule. But notice how there's a minus here. This is a plus. What do we do?
Wait, so R is always going to be X?
Yeah, you can pretend that R is X, essentially.
Plus X.
But there's a minus. So how do we get that? We do 4 minus negative X. Because 2 minuses equal a plus. Do you understand so far?
Okay. Where did you get A minus 1 over R from? That formula.
That's the geometric form. That is an official formula. Like, I didn't make it up. It's literally just the geometric form of a power series.
Why don't they put that one instead of A over 1 minus R? Whatever, it doesn't matter.
What do you mean, why?
Like, if the key formula is A minus 1 over R, then why is the formula at the top a over 1 minus r?
You're asking why they put it as 1 over x plus 4?
No. Never mind. I got it.
Well, the reason why they put it as 1 over x plus 4 is to complicate your life. Like, if I'm gonna be completely honest. And they want to see how you can manipulate. But basically what I've done so far is I've manipulated this so that it can slowly but surely start looking like a over 1 minus r. Does that make sense?
Yeah.
So look, a is going to be a random number. Notice how it's just a, but this has to be 1. It literally has to be 1. So how do we get 1 over here? You have to divide over 4, right?
Yes.
But then you also have to divide this over 4 and this over 4, because what we do to one thing we have to do to everything, because we can't just change the expression like that. That's the most important part of this lesson. Notice how at this point all I did was flip these two. I didn't change it, right?
Exactly.
At
Okay.
this point I didn't change it because this can be rewritten as a plus. Notice how it's the exact same thing as that and the exact same thing as that. I didn't change it, right?
Yeah.
All right, so let me undo a few of these things. Now, at this point, I can't. I like we've done all this work so far. We haven't changed a thing. I don't want to change this either, but I want this to look like 1. So really, you're dividing everything by 4, and that's why I did 1 over 4 over 1 over 4, because I'm dividing every single thing by 4, and you're left with
Is the other thing that
1.
still correct still? The 1 over 4 over 4 over 4 minus, like, that's still correct though.
What do you mean?
You
The
have
reason why this is correct is because 1 over 4 over 1 over 4 is 1, and anything times 1 is the same thing as itself. Does that make sense?
Yeah, but then why did you change it from before? You used to have 1 over 4 over 4 minus negative x over 4.
Say that again, Julia.
Before you used to have 1 over 4 over 4 minus negative x over 4. But then you erased that and made it times 1.
Well, because it's the same thing. That's the same thing. When you distribute this whole thing that I created over here, I actually prefer doing it this way because it makes it clear to me that we're not changing it. When you distribute everything, you're left with 1 over 4, 4 over 4 minus negative x over 4, which is exactly what I wrote, right?
Yeah.
That's all I did. So now you're left with 1 over 4 over 1 minus negative x. It's not letting me write.
I get it. Okay.
You
I had
got
to
it?
visualize it. I'm sorry.
Say that again?
That I had to visualize it. I'm sorry.
Don't worry. Julia, I've already told you that, like, I know that this lesson is very hard. So don't worry. So this is what we're left with. This. So now it looks like this. Now we can align. So this goes with A and this goes with R. So we know that the A is 1 over 4. We know that the R is negative x over 4. Does that make sense?
Yeah.
Okay, so now the reason why we're doing this is because we want it to look like this, because this is the form of a power series. This is just like an alternate form, but it's not the official thing. It's just like a little hint to tell you that, hey, when it looks like this, you're probably going to be able to do this. So let me erase all this mess and tell you how to get to where the final answer is. Let me see.
So r was negative x over 4.
R is negative x over 4. So now all we're going to do is plug in. A is 1 over 4. R is negative x over 4. This is n. Let me move the page up a little bit. We're almost there, Julia. We're almost there for this geometric. What I'm going to do now is just rewrite this in terms of like things to the n, because if you look over here, this is the final answer. It's not in the exact same form. They like to just write things like with x to the n. Like they like every single thing to have n, if that makes sense.
Okay.
So the 1/4 stays. This is now -1 to the n, x to the n, 4 to the n. For every single term that I saw, and when you break this up, this -x to the 4, it's really -1, x, 4. I just gave every single one an exponent.
That's so stupid.
I know, like I can't, I wouldn't say anything because like my whole time, like the whole experience we've been doing is like we had to do these steps to get it simplified. But I would imagine that this could be right. Oh my god. I would imagine that this could be right on the AP test. I just don't know. Like there must be a reason why we've been simplifying. So I can't tell you for sure.
Okay.
But at this point, you can literally just simplify this to the answer we currently have. Just multiply the numerators times the denominators. So 1 times this, you're left with -1 to the n times x to the n. 4 times 4n is 4n plus 1 because you're adding the exponents. And that's the answer. Does that make sense, Julia?
Yeah.
Hopefully, kind
I
of.
have a question.
Yes?
It's a never mind. It's a dumb question.
Tell me.
No, I was gonna say like I would have made a stupid mistake. I would have multiplied the 4s and put 16 to the end.
Remember that when you're multiplying two things, you're adding the exponents.
Because would it be 16 to the end if the 4 was in parentheses? Or no, not never mind. Still not yet.
No.
You just have to pretend like there's a 1 on top of the 4 and then do the 4n plus 1.
Yeah, because unless it's literally 4 times 4, you cannot multiply the bases. You add the exponents. That's how you do it.
Okay.
Okay. So now I'm gonna move on to the last big important topic. Oh, I don't know why it's doing this. Hold up. Give me a second. Oh my god.
Well,
I
I'm
do not.
back and then you're back.
What?
I'm gonna use the bathroom.
Wait, I think I'm gonna figure it out. I just don't want to waste time because it's already kind of late.
Okay.
Um, give me a second. I'm just trying to figure this out because I do not know what happened to everything. Do you guys still see the screen?
Yeah, it just says couldn't preview file.
Let me try this. Okay, you should see it now.
Yeah.
This is another geometric one. This is another geometric one. Okay, I want to show you these functions. These are really important. These are elementary functions. Okay. Actually, no. I'm gonna do this Maclaurin, and then I'm gonna show you this. And I'm gonna show you how this problem can be done 2 ways. So, Maclaurin, Julia, tell me what you do.
Maclaurin is the one with 0.
Yes. So what's the form for Maclaurin is, remember, you start with the first term plus f prime of 0 over x times 1 factorial plus f double prime of 0 x squared over 2 factorial, and then so on and so forth, right?
Yeah.
You remember that?
Yeah.
All right, so how do we find the Maclaurin series for this? We're gonna stop at 4 terms. So I know it doesn't say it, but we're just gonna do 4 terms. How do we find the Maclaurin series? We're just gonna take the derivative a few times and stop until we have 4 terms.
Okay.
And then that's gonna be the series. So, and remember that since it's Maclaurin, x is equal to 0. So that's why we're plugging 0 here. So, let's start. The first thing is f of x is equal to cosine of 2x. Aaron, did you say something?
No,
Okay, I thought you did. I'm sorry.
it's okay.
So Remember, we're going to be plugging in 0. So when you plug in 0 to this first one, you get 1. Does that make sense, Julia?
Into cosine of 0?
It's a cosine of 2x.
Okay, yeah.
Okay, so we're just going to keep going. And remember, we're going to do it up to 4 terms because that's like the general, like, that is like your go-to term limit. So the next one will be f prime of x, which is negative 2 sine of 2x. When you plug in 0, you get 0. So if we were plugging this into the Maclaurin series right now, this number would be 0, and it would just get rid of this term. So technically, that's not our second term. It doesn't work. It just doesn't exist. So we'd have to go to the next one. So we're going to take the derivative a few times because we're trying to aim for 4 terms. Say that again, Aaron.
Could you remind me again why the x next to the f of 0 isn't also 0? Like, I know that's part of the x minus c thing for like the Taylor series, but why is that one not also plugged in?
Because I made a mistake. This is technically supposed to be a c, like you said. And really what you're plugging in is the c value here. So it's not really an x, if that makes sense.
Oh, okay.
That's why. I just write that because, whatever, it's easier. So the next term, we're just going to keep taking the derivative. This is negative 4 cosine of 2x. I'm going to just do it a few more times. And I'm going to stop to the 5th. This one is 8 sine of 2x. This one is 16 cosine of 2x. This is negative 32 sine of 2x. And anytime you see a sine, it's not going to really exist. But when you plug in, whenever you see a cosine, you can just assume the coefficient. For this example, I'm just going to do 3 terms because I don't want to do more derivatives, if I'm going to be honest with you guys. But like, do 4 terms. That's what Miss Q said to do. So basically, for this particular problem, we're just going to assume this. And we're going to write out the series. So same thing as before. So remember, the first term is f of 0. So f of 0 is 1. The next term is f prime of 0 times x over 1 factorial, which is 0. So I'm going to write 0 there, but you can eventually get rid of it. The next one, f prime of 0, or f double prime of 0, x squared all over 2 factorial. So f double prime of 0 is negative 4 x squared over 2 factorial. And so on and so forth. So the next one would be 0 again because we're on this one, and that's a 0. The next one, you'd plug in 16 x to the 4th over 4 factorial, and then you just keep going.
Okay.
This is technically right, but I would like go one more step to simplify. So here, let me just erase this little part, these little parts over here.
Just putting it until you have terms that aren't 0. You have 4 terms that aren't 0.
Yes, exactly.
Maclaurin series that we've done.
Say that again, Julia.
And it's the same Maclaurin series that we've always done.
Yeah, it is. Exactly. That's why I think it's like, it's an easy way for you to get points for this test. So at this point, we're just gonna write it without the zeros. So it's this negative 4x squared over 2 factorial plus 16x to the 4th over 4 factorial. And notice how this matches up, this matches up, this matches up. This would have been the next term if we had actually written it. But yeah, whatever. We only wrote 3 because in the interest of time. So does that make sense? That's what the answer is.
Okay.
Not too bad, right?
Yeah.
Okay, but now I'm going to tell you how this could have been done without taking the derivative. So you need to have these handy. You need to. Like, you absolutely have to. And look, this is because this whole chapter is power series. This was just a Maclaurin power series. But notice how it follows the same rule. We know that this original problem was cosine of 2x. And this formula here, this big image, it gives us the formulas for all these like different series. And cosine of x is right here. So we could just use this formula to figure out what cosine of 2x is. Does that kind of make sense to you?
Yeah.
All right. So now we're going to do that. So if we're just going by this formula over here, oops, sorry. I'm gonna write it. I'm just gonna do it on this page. It was asking for cosine of 2x. We know that cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial plus dot dot dot. What's the difference between these two, Julia?
The 2.
The 2. All right. So how do we get from here to here? Well, all we have to do is plug in a 2x whenever you see an x here, because all we're doing is changing it to 2x. Does that make sense?
Yeah.
So this now becomes, I'm going to plug in a 2x here. I'm going to plug in a 2x here. I'm going to plug in a 2x here. And when you end up simplifying this becomes 1 minus 4x squared over 2 factorial plus 2 to the 4th is 16x to the 4th over 4 factorial. 2x to the 6th.
What do the questions look like when they ask this?
What do you mean?
Like, what will it ask?
It's just going to ask you for like the series of cosine of x.
Sometimes, because I think I saw on one of the do nows, it was, or not do nows, the just do it's, that it was like use the elementary function for the cosine of x or the e of x to figure out e to the negative 4x or things like that. So they might
Exactly.
do that.
So
Yeah.
like 11 and 12 aren't the elementary functions, are they?
What do you mean 11 and 12?
Like questions 11 and 12.
I'm sorry, I'm not looking at that right now, but we'll scroll to it in a second, but
So
this is the answer we got when we just plugged in 2x to the original, like the elementary function. These are elementary functions. And notice how, let's scroll up to the one that we just did. It's the same answer.
So this is really just plugging
It's
and
plugging in.
tell you into the elementary function
Yes.
and simplifying.
Yep.
Okay, that's not too bad. That's good.
Right?
Yeah.
11 and 12 are the same thing, except that there's a little more manipulation.
Is it Maclaurin or is it's Maclaurin?
They're all they're all Maclaurin.
Okay. So you didn't give elementary functions, you gave the elementary thing because you explained it. I got it. Perfect.
Yeah.
Okay.
Here's one with like an elementary like Julia, this is technically an elementary function right over here. Like this one. An elementary function is just a basic function that you're expected to know, and they're basically telling you how to get to it, essentially. So like here for this one, it's telling you that it's not saying it's an elementary function, but it technically is. In order to get this one, all you would do is look, notice how the only difference is x. This one has x over 3, the other one has x. So whenever you see an x, you just plug in x over 3.
But
And
that's
so on and so forth.
minus x.
What?
That is 1 over 1 minus x.
Yeah, but notice how the only thing that they changed with the x value was that this new one has x over 3.
Oh, so you just plug in x over 3, so it'd be 1 plus x over, okay, got it. I get it.
Because in the previous example we did, here, let me just go back to it. In the previous example we did, we're looking at the x value to see what we plug in. So it doesn't matter what everything else is saying as long as we're looking at the x value.
Okay.
That's the thing we're changing. So I guess I want to just use this one to kind of show you guys how to do this last one over here, number 11. We're going to use the cosine of x elementary function as we would, and since I already have it written down, I think it's easy to do. All we're going to do is just do what it says. 1 minus cosine of x over x. So let's do it. 1 minus cosine of x over x is 1 minus, it's all of this, because this is what cosine of x is equal to. You know what I mean. Plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot 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 all over x, right?
Yeah.
Let me erase this because we've already used it. Notice how when you do a 1 minus this, you're just going to be changing a few of the terms. We're going to flip the sign for all of them because it's 1 minus. So it's 1 minus 1 plus x squared over 2 factorial. We're like distributing it to each term. Does that make sense?
Yeah.
Minus x to the 4th over 4 factorial plus x to the 6th over 6 factorial plus, this is really minus dot dot dot. And this is all over x. 1 minus 1 is 0. So now we can just assume it with this series. So now all we have to do is divide each of these by x. So really it's like you're multiplying everything by 1 over x, right?
Yeah.
So at this point, and this shouldn't be too hard to see, minus dot dot dot. But if you multiply each one, the x will cancel one exponent on the top. So now you're going to be left with a 1 over here, a 3 over here, and a 5 over here, and so on and so forth. So actually, if we look at the answer, here, let me undo that. If we look at the answer, it's this over here. This over here. And notice how it's the same as this. This is x over 2 factorial minus x cubed over 4 factorial plus x to the 5th over 6 factorial. And notice how that's exactly that. So does that make sense, Julia?
Yeah. Thank you.
All right. So I'm going to stop the review. So I'm going to stop recording. Thank you guys.